Hey everyone, hey everyone. Today we are going to be covering two objectives. The first is going to be different compounding periods, and the second is going to be interest rates. So let's begin with the first objective, different compounding periods. Now the reason why we're looking at this particular objective is because previous mathematical work has shown that we've been using just the years, okay? All investments have a year's difference between one interval to the other, okay? But there are many accounts and many investments in real life that don't just follow a yearly perspective. What if I said find the future value of a particular amount such that the investment is compounded quarterly, monthly, weekly, or even daily? These are things that do occur in real life, and therefore we really want to look at these and see what further mathematical calculations must be done in order to get the right answer. Now the best way to explain this is to do it with an example. So this example says find a future value of $120 if it is invested in an account that offers 10% per annum for 5 years. Okay, now this looks like your standard question and you should be able to do this. But what if I mix it up? So I have this and here, okay? And this particular investment has the two following features. And for the sake of this question, let's just assume that, alright, this investment has this feature, but it also has this feature, the second feature, and we'll calculate them both so we can see the type of calculations that will arise. But this in particular investment, the interest is compounded monthly. Okay, it's not compounded yearly, it's compounded monthly. Okay, and we are also going to investigate what happens if interest is compounded weekly. Now, before we begin, there is a little rule that I just suggest you to remember, and just make sure this sticks onto you. So whenever you have these type of questions where the compounding periods are not yearly, all you must do is this. You divide the rate and you times the time. So this is what should be sticking, what we should be sticking to you. You divide the rate and times the time. Divide the rate and times the time. Divide the rate and times the time. Keep saying it until it sticks onto you. So we understand that the rate is going to undergo some division process and the time is going to undergo some multiplication process. But the question is, what amount is it? What number are we dividing by or multiplying by? Well, let's do this question. So we want to find the final value of this amount, okay, assuming that interest is compounded monthly. The future value is going to be equal to the initial $120 outside of 1 plus. Now we know that in this box right here, well, not a box, but in this space right here, we write the rates. Okay, but our rate, it has to be different. It has to be different to this 10% for the fact that interest is being compounded monthly, and this new rate is given by dividing 10% by 12. By 12. So you divide the rate by 12. Why 12? Because there are 12 months in a year. And in the same way, the time is meant to go in this particular space. If it was compounded yearly, the time would be 5. However, it's being compounded monthly, so the time becomes 5 times 6, no, not 5 times 6, 5 times 12, which is 60. Sorry for that error. And so this is going to be the final amount, or the answer is going to be the final value of $120, given that this investment undergoes compound interest monthly for 5 years. And it makes sense. If it's going to undergo compound interest monthly, it's going to undergo compound interest 60 times. Okay? 12 times every year for 5 years is 60. And the rate has to be divided by 12. And so, just doing some calculator work, we'll see our answer is $197.44. Okay, that's the answer for this part. Now, there's a reason why I didn't simplify this expression right here, 10% divided by 12. I left it like this so it can be in exact form. Because if you were to evaluate this expression, you would have a recurring decimal or something that's very long and very ugly. And so if you leave it in the exact form, it'll look a whole lot nicer. Okay, so that's for the first part, such that interest is compounded monthly. Now, what if interest is compounded weekly? Well, a similar process will take place. The final value is going to be equal to $120, so the initial value doesn't change, outside of 1 plus the interest rate. What's the interest rate going to be? The new interest rate is going to be 10% divided by 52. 52 because there are 52 weeks in a year, a normal year at least. And how about the time? Well, it's going to be 52 times 5. And that's 260. Okay? And so when I evaluate this, it's going to give me the final value of a $120 investment, such that interest is being compounded weekly at 10% per annum for 5 years. Okay? So our answer for this part is going to be $134.66. Oh, sorry, I did a mistake. Hold on. It's going to be $197.75. Okay, $197.75. And notice how this is in fact larger than the final value of the investment, such that it was being compounded monthly. Okay, so that ends the first objective, and I just want you to remember that whenever you're given these types of scenarios, always divide the rate and times the time, and it'll get you to your destination. We're now going to look at interest rates. Okay, interest rates. There are many things to talk about when it comes to interest rates. So, you know your casual interest rate. You know, when someone throws at you, hey, you know, this investment will get 5% per annum, that's your stock standard interest rate. But there are different types of interest rates that we must look at, because some interest rates give us more information and thus allow us to make more comparisons between accounts, and that can be very helpful. So we're first going to look at the annual percentage interest rate. This is also known as APR. Okay, and its definition is the interest rate expressed in annual terms and qualified by the payment made each period. It's also known as the quoted interest rate and the nominal interest rate. Okay, the quoted interest rate and the nominal interest rate. So the APR is simply the annual interest rate, your stock standard interest rate. So it's the normal interest rate. But what's of more importance in this objective is the effective annual rate, also known as EAR. Now, the effective annual rate is the interest rate expressed as if it were compounded each year. Okay, so what does this actually mean? I'll explain it in an example so you can get a better understanding of what I'm talking about. But the reason why we investigate, or the reason why we give such focus to this particular interest rate, is because it allows us to compare it allows us to compare investments. And that's very important. If I say here are 3 opportunities in where you can make an investment in each one, which one would you take? Given that there are different compounding periods, well, you'd relate to the EAR. So here's an example. We have 2 investments, Bank X. Now Bank X offers 12% per annum, compounded annually. And Bank Y offers 12.5% per annum, compounded quarterly. Which is better? That's the question, which is better? And the simplest way to do this is to ask yourself, okay, let's say I have $1, okay, so I'll just put this up here. So which is better? The thing is, say we have $1. Okay, say we have $1 and I put this $1 in this account and this $1 in this account. It should make sense that I calculate the final value of this $1 in both accounts, I compare them, and then I can find out which one's better. And that's the simplest and most intuitive way to do this. Okay, so say we have $1. Bank X says this: hey, your future value is going to be equal to $1 times 1 plus 12%, all to the power of 1. All to the power of 1. And so the final value of this $1 is going to be equal to, and sorry, it looks like a 4, is going to be equal to, oh, I should have been able to do this straight away, $1.12. Very straightforward. But what about Bank Y? What does Bank Y promise me? Well, Bank Y's conditions is you'll get 12.5% per annum compounded quarterly. Now from the last objective, you should know that the final value is going to be equal to 1 outside of 1 plus 12% divide the rate times the time. It's going to be 4 times 1, which is just 4. And so the final value of this investment, Bank Y, is 1 plus 12% divided by 4, all to the power of 4. And that's we'll just do it to 3 decimal places for now. Okay, $1.126. So clearly it makes sense that Bank Y is the better, offers the better investment. But what's the EAR? Okay, what's the EAR? Because that's what we want to calculate. Well, let's get at the definition of EAR again. EAR is the interest rate expressed as if it were compounded each year. Okay, so what I'm saying is the EAR for Bank X is still going to stay the same because it's compounded yearly, and this, in consequence, should be the same as this because this is annual, this is year. This is year, this is year, this is annual. They should have the same number. But Bank Y, right? Bank Y offered an interest rate of 12.5% per annum. This was the APR. Okay, but what's the EAR? Well, you can get the EAR straight from here. Okay, it's actually 12.6%. Because this guy right here would have to be 12.6% in order to yield this, as this was 12% and that yielded 1.12. There is a direct relationship between these two things, given that this was 1. Okay? And so the EAR for Bank X was 12%, the EAR for Bank Y was 12.6%. and this also justifies that Bank Y is the better investment. And that concludes this lesson.